And here we go. So today we're going to look at 1-1, chapter 1, lesson 1, rate. So go ahead and write this down. This is your title, 1.1 rates. All right, so 1-1 rates, and then right under that first line, so you should be writing this down, you're going to write EQ, which stands for essential question. The essential question is the kind of like the overarching theme, or it could be just a certain question of what we're trying to accomplish. When you write your summaries, it could be what you answer. So the essential question is essential to the lesson, thus essential. All right. Today's essential question is this. Why is it important to find unit rates? Okay, why is it important to find unit rates? So we're going to talk about what a unit rate is, and we're going to talk about what it does and why it's useful for our lives. Hopefully you'll get an understanding of that. Okay, so go ahead and write that down. I'll give you guys a second. All right, so first let's start about what is a unit rate. Let's talk about what unit rates are. So on the left, remember on the left side is where I put like headings and subheadings and whatnot. So our first thing is going to be unit rate. What is unit rate? And in order to understand unit rate, you're going to first have to understand what rate is. Now, if you're someone who likes color, you could, underline or highlight these vocabulary words. That's I'll leave that up to you. Okay, so the first thing is a rate. What is rate? Okay, rate is a ratio. So ratio is like a fraction, okay, that compares two different units. For example, miles per hour. Okay, those are two different units. Miles is a unit of measurement, distance, just like inches or feet or yards or whatever else. Okay, hours is a measurement of time, right? So if you're measuring time, then that's separate. So it's comparing two different things. So you see that all the time: cost per ounce, price per bag, miles per hour, feet per second, all those sort of things. Okay. Now, if I was to measure, for example, how long is my hand versus how long is my foot, that's not a ratio, that's not a rate, because it's measuring the same thing, inches and inches. Okay, it's got to be two different kinds of units. Now, a unit rate is simply this, and again, I'm going to use this to kind of highlight it there. Okay, a unit rate is simply a rate with W with the slash is how you write with. Okay, with denominator of 1. Okay, the denominator is 1. So let me give you an example of that. So a rate, for example, is if someone said, hey, how fast was that car going? Right? And you wouldn't say, oh, it's going 100 miles in 2 hours. No, you would say it's going 50 miles in 1 hour. That's a unit rate, right? 1 is the denominator. It's all, we divide so that 1 is the last thing. So it's always per hour, per month, something like that. So if someone asks you for example, how much anime do you watch? And you say, oh, well, I usually watch I watch an episode each day. Okay, some of you are like, that's it? Okay. Each day for 1 day. You don't say I watch 7 episodes in 7 days. You say I watch an episode each day. That's unit rate. Okay. So let's do some examples, and this hopefully will make it a little more clear. Okay, let me do an example first. Don't write this down. Okay, do not. So if I write this EX, don't write that down. Okay, so here's an example. Let's say that you were running a marathon and you ran the first 24 miles in 4 hours. Okay, this is a rate. All right, again, you don't have to write this down, just watch. This is a rate. Now, I want to turn it into a unit rate, so I'm going to do this. I'm going to say, okay, 24 miles in 4 hours, and I'm going to divide, right? That's what you do. You divide by 4. Right? I can put it in my calculator, or in this case is actually pretty easy, and I can say, okay, well, that's the same thing as 6 miles per 1 hour. This is the unit rate. Okay? So again, this right here is example of a rate, and this is a unit rate. Does that make sense? Right? Now, you can write this a lot of different ways. So you could write this 6 miles per hour like this. You could write it like this, 6 miles per hour. That's okay. You can even write it out, 6 miles per hour. Any of those would be perfectly fine. All right. Okay, so let's have you guys do one. Okay, again, you didn't have to write that last part down. Let's do this one. Letter A, which means you do write it because I'm giving you a letter for it. Okay, let's say you had a job and you made a whopping $300 in 6 hours. $300 in 6 hours. All right, write this down. And then some of you guys are like, this is really easy. Go ahead, figure it out. If you can figure it out, go ahead and figure it out. Okay. So you do the work here, and now a good key is money always goes on top and time always goes on the bottom. So I'm going to do it like this, 300. I'm just going to divide, put that in my calculator, right? Should be no problem. Okay. And did you guys get $50 per hour? Is that what you got? Yes? Okay. Easy, right? Now, what's important to note, okay, is notice how I used the units. I said dollars and hours. I did not just say 50 was my answer, okay? Units are important. And let me explain to you why units are important, okay? Let's say you were wanting to go to the store and you wanted to buy a bag of chips and an Arizona and some Sour Patch Kids. And you said, Mom, give me 5. And she said, huh? You held out your hand and said, Mom, give me 5. Mom, I need 5. And she said, okay, there you go. No, you need 5 what? You need $5, right? You need to say what you need, right? If someone says, hey, go to the other room and grab me 10. Huh? 10 what? 10 shoes? $10? 10 pencils? Like, you need to make sure that you are using your units to explain what the numbers mean. Otherwise, they're just random numbers. Okay? Okay, so let's go ahead and do another one. Letter B. Here we go. Let's say 4 bags of chips. Here's the rate. For $2.12. Go and find the unit rate for this one. All right, so go ahead and work that one out. Again, use a calculator. You're supposed to be using a calculator. Okay, well, let me ask you this. Did anyone get 1.88, 1.89, something like that? Anybody? Some of you are nodding yes. Okay, did anyone you get 0.53? Ooh, nodding yes there. Okay, those are two possible answers. One is wrong, one is correct. If you got if you got 1.88, okay, if you got 1.8, you did something wrong. Think about it this way, okay? If you get 1.88, does it make sense for 4 bags to cost $2.12, but 1 bag to cost $1.88? Does that make any sense? No, right? I'm not going to pay 1 bag $1 if I can get 4 for $2, right? So it's got to make sense, okay? It's got to be something that you have to look at the answer. Don't just like do the math. Sometimes we do the math and we make it and we're like, oh, we're doing it right? And then we end up that we're not actually doing it, okay? Or we did the wrong step, and that's okay as long as we correct it. So we have to remember money always goes on top. So we got to put the 212 on top and divide by the 4 bags. So if you messed up, redo it in your notes, okay? Erase it and try it again, right? Go ahead and work this out. All right, and you should have gotten 53 cents per bag of chips. Okay? Right? That should make sense. That makes more sense. Oh, well, yeah, I'm buying 4 bags. Only each one costs about 50 cents. That makes more sense. Okay? So it's okay if you get them wrong. You just have to understand that, hey, I need to use common sense to see that if it does make sense. Okay, so let's move on. The last example we'll do for today, okay, is finding the best deal. All right, on the left side, I'm going to write find the best deal. That's what we always want to do. We always want to find out the best deal, right? We want to find out what is the lowest cost. We want to save the most money, all of that, okay? So we are going to do this to find the best deal, all right? I'm going to give you an example here that I want you to copy down. Let's say you are really jonesing for a peanut butter and jelly sandwich. You're like, oh, I really want a peanut butter and jelly, but I just don't have any more peanut butter left. Okay, well, I'm going to go to the store and I'm going to go buy some peanut butter. You get to the store and you see that there are a couple different options. You could buy the 12 ounce, the small jar, but that's gonna cost you $2.19. You could buy the 18 ounce jar. That's gonna cost you $2.79. You could buy the bigger jar, the 28 ouncer, and that could be $4.69. Or you could buy the biggest one because you really like peanut butter, 40 ounces for $6.60. Okay. So here are your 4 options. So go ahead and copy this down in your note, letter C. So the question is, which one is the best deal? Now, it's not asking which is the cheapest. The cheapest is easy. The cheapest is the 12 ounce. It's only $2.19. But is that actually the best one to buy? Is that the one that gives you the best per ounce? We have to the only way to do this is find out how much it costs per ounce, right? We want everything to be on the same playing field. So it's kind of like, let's say you're going to race somebody and somebody ran a mile and somebody only ran 100 feet. Could you really tell who's faster? No, because they're not running the same distance. So this one, we have to compare it by the same thing. We have to compare it by their ounces, per ounce, the unit rate. Okay, so how do I do that? Well, just do what we did on the last couple problems. We divide. I'll do this first one here. $2.19 divided by 12 ounces. Go and plop that in your calculator for me. All right. So 219 divided by 12, you should have gotten 0.1825. Yes? Yeah? Okay, do the same thing for the other 3. Go ahead and do the same thing for the other 3 the other 3 ounces, and let's see if we can find out the best deal. Give you guys a minute to figure that one out. Okay. All right, someone send me an answer. That's good. I'll let you know if it's correct or not. All right, so you're working on that. You got 4 different things. Okay. And it's probably creamy peanut butter. Some people, I found that not that many other students like crunchy. Anyone here like crunchy peanut butter? Some people are like, nah, that's gross. I like creamy better too. All right, Alvin got me an answer. Thank you. Pretty good. Good. All right, let's check it out. All right, so for this one, the second one, you should have gotten 0.155. Yes? And the third one, you should have gotten this 0.1675. And for the last one, you should have gotten 0.165. Is that correct? Yeah? Okay, so which one, 1, 2, 3, or 4, show me with your fingers, is the best one? 1, 2, 3, or 4? Ethan says 2. Alan says 2. Stella says 2. Peyton says 2. All right. Okay, most people are giving me... Okay. Yeah, if you look at the numbers, you go by the one, whichever one is, Joseph says 2, you go by the one that says is the cheapest, right? So in that case, it's going to be this one right here, the 18 ounce, okay? The 18 ounce is the best deal. Now, you might say, well, Mr. Leon, I want more peanut butter. Well, think about it this way. Instead of buying like a 40 ounce, you could buy 2 of the 18 ounces, right? 36 ounces. And it'd be cheaper than if you bought it the other way. So that's what we're talking about here. Now, you might say, well, I just want a lot of peanut butter, so I'll buy the biggest one. Okay, that's fine, right? But the biggest one's not always the cheapest. Sometimes the other ones are on sale, and so you have to look at it. And if you ever go shopping with your parents, you'll see that. They list the ounce per ounce price on most things. So you can do that. So you can comparison shop. Okay, so that's what you're trying to do here. You're trying to figure out the best deal, right? And again, now, what I want you to notice how I didn't really round these numbers off. Because if I would have rounded them off, I would have gotten in trouble. Let me show you. These 2 numbers look very much the same. And let's say I rounded it. So let's say I rounded this one 0.1675. If I rounded it to 17, it'd be 17. I'll put that in different colors so you can see. And if I rounded this one, it would also be 0.17, right? So if I rounded these 2, they look the same, right? But they're not the same, right? We know that they're not the same. One of them was bigger than the other. One of them was not as cheap as the other. So when you look at these numbers, okay, you don't want to round too early because you'll see that this one is 0.16. This is 0.16. If I stopped right there, then they'd look the same. But this one right here, the third one had a 7, and this one had a 5, which means if you're to compare these 2, this one is cheaper. Does that make sense? Right? So make sure you don't round too early. That's another big thing.